Hi students, in today's lecture, we are going to see the actuators and drive circuits for the robots. Okay? So in the previous classes, we have learned like the basics. Where do we use actuators? So for example, if this is your manipulator, so this is link 1 and then this is link 2. So you have a gripper. Then this link makes an angle theta 1 and then this link makes an angle theta 2. Okay. Suppose if I want to actuate this particular joint, what I have to do is, so already for each joint, you have a sensor, you have a motor, you have a gear arrangement. Okay, so to this motor, we have to give a signal. We have to give a voltage to this motor. Then this motor takes the voltage and it has a shaft. So that shaft will rotate this. So this rotates this joint. Then accordingly, we can make the link to move from this theta 1 to theta 1 dash. So for this, to actuate the joint, we need actuators. So in this class, we'll see what are the various actuators that can be used in robotics. Okay. So here the electric motors, brushed DC motor, stepper motor, servo motor, and we are going to see the driver circuits. Okay, driver circuits in the sense we are going to control the voltage, armature voltage from the motor, so that the link will be or the joint will be actuated. Okay. First, what is an actuator? So, actuator is a device that brings about mechanical movements required for any process. Or we can say that actuator will convert electrical form of energy to mechanical form of energy. So, when you give voltage to the see you have a windings. When you give voltage to the windings, then this is energized. So you have a coil here. So this coil will also be magnetized, and then if you attach any core to that, so as a result of this will rotate, so the shaft will rotate. So you can use that shaft rotation for actuating the joint. So for actuators, there are two important circuits: signal amplifier and transducer. Signal amplifier convert low power control to higher power, and the transducer converts one form of energy to the another form of energy. Okay, so whenever you give a digital control signal, first you have to amplify it so that it will be given to the transducer, and it converts that signal into mechanical process. These are the energy transfer types of energy transfer to actuate the joint. So that energy transfer could be electrical or a mechanical form of energy, or pneumatics and then hydraulics. So we'll see this electrical part. Okay, so we can take this example. Suppose I want to move this turntable. If it is an open loop control system, directly the because the voltage is already predetermined, so that with that voltage, this turntable will be rotated using this motor. Okay, so the predetermined voltage is given by the battery. Then in order to rotate this, we need some amplification. So amplifier, and that is given to the motor. So this is actuator voltage. So when this voltage is given to you, the windings get energized, and then the core attached to that will rotate. As a result, the table which is attached to the shaft, motor shaft, will also rotate. So like this, we can turn the table. But this is open loop. We don't know what is the current one, and then accordingly how much we have to turn. So that information we don't know, but we predetermine. Okay, we think that okay, this voltage is enough, but sometimes it won't work, or most of the times it won't work. So in that case, we have to go for closed loop control system. Okay, so how do we do that? First, we have to measure. Okay, using tachometer, which is used to measure the turntable speed. So the tachometer speed is measured, and already predetermined is compared, and then it will give you the error, and then that error is given. I mean, how much uh, it has to be given more or less. So that is amplified, then that is given. If that is given, then we can say that it is under closed loop. So here the tachometer is a sensor, and then the controller is the amplifier, and then actuator is the DC motor. So we can control the robot joint either in terms of open loop or in terms of closed loop. Okay, let's see the first actuator, which is DC motor. So DC motor has the stator and rotor winding. Then when the voltage is given to the stator, so this is energized automatically, that is induced in the rotor. So the rotor will also be rotated, and then since it is connected to a shaft, the shaft will rotate. So in this, to this shaft we can attach the link of the robot. So as the shaft rotates, the link will also rotate, or the joint will also rotate. Okay. So we'll do the mathematical modeling of the DC motor. So let's take, in the DC motor you have resistance, which is armature resistance, and then you have inductance as well. This is LA, and then this is the motor part. So here we can say that the back EMF produced, and then to this you have a shaft, or this link is attached. So as a result of this, this will be rotated. So this rotate at this speed, I mean the armature velocity. Okay, then this is the circuit. So here this is the armature voltage, here is the current. Okay, how do you write the equation using Ohm's law? VA equal to IARA plus LA DIA by dt plus VB, back EMF. Okay, and then back EMF is proportional to theta A dot. So in order to remove the proportionality, we can have back EMF constant theta A dot. Okay, then the torque, the armature torque is proportional to IA. To remove the proportionality, tau equal to kT into VA. Okay, so we'll substitute in this. So always the inductance is very less, meager, so we can equate this to 0. So we have armature voltage as IARA plus back EMF is KB into theta A dot. Okay, then if you want to replace this with this, so VA equal to tau A is KT into IA, but what is IA? Tau A by KT. So tau A by KT into RA plus KB into theta A dot. So let's draw the joint control system. So here is the joint control system. So to this joint, this motor is attached, so this will provide you the desired torque. So this desired torque is given to driver circuit, because we cannot just like that give the voltage to the motor. We should have some coordination, we should have some schedule, so that is controlled circuit. So we should know that on what time we have to give the voltage, or which winding should be energized. So that is decided by driver circuit. This is very very important. So this will give you the armature voltage. Then the armature voltage is given to the DC motor, and then the DC motor is attached to the joint. The joint will give you either angular position or angular velocity. So that is measured and fed back, because this is a closed loop system. Okay, so this is theta, this is theta dot, this is angular velocity. So how it works is, so this is the joint. So this joint, okay. Now let's take this joint. So we have a control system for each joint. Already we have discussed that the each joint should be controlled independently and similarly. Okay, so here you have this joint control system. Here, for example, let's take this is joint 2. So we have one block, joint 2 control system. Okay, to that joint 2 control system, this theta and theta A dot is given. How? See, here you have gear, here motor, and then here sensor. This sensor will give you this information. The sensor information, which is angular velocity and angular position, is given to the joint control system. Okay, then the joint control system, it has the set point, which is already implemented in that. It calculates the theta and the theta A dot velocity, and then it will give you the torque. So using this equation, it will give you the torque, and then the torque is given to the driver circuit. So here this is the current value, this is the requirement. Then based on that, it will tell you how much torque should be given. So that is called, this is the desired value. This is the desired value. So how do we get this desired value? Already we have the goal, we have the required point, and that is compared with the current value using the sensor. Then the value is decided. The decided value is given to the driver circuit. So in the driver circuit, we have a sequence that is for t equal to 0 to 5 seconds. You have to switch on this. For example, the windings are W1 and W2. So for 5 seconds, you have to enable this. Or for the next 5 seconds, you have to cut off the power supply and you have to enable this. So this kind of logic is implemented in the circuit. So the torque is given to the circuit. Accordingly, it produces the voltage VA. So here we can say. So based on that, this is a constant, the desired one. These are all constant. Okay, so this is the actual one which we have measured already. This is also constant. So automatically VA will be produced. That VA will be given to the motor. So who supplies this VA? This control system. So it gives tau A, then that is given to the motor circuitry, and then finally we'll have this VA. This VA is given to the motor. Okay, so see the flow. So the sensor is given to the joint control system. Accordingly, it generates the desired torque. The desired torque is given to the circuitry. The circuitry will decide when to on the particular circuit or when to energize the windings. Accordingly, it produces the armature voltage. That armature voltage is given to the motor of that particular joint. So that motor is with the joint. Then again, based on the input voltage, the joint will be moved. So suppose if the joint will be moved over here like this. Okay, again, this position is measured and the position velocity is measured, then it is given to a joint control system. Again, it gives the torque. The torque is given to the driver circuit, which produces the armature voltage. That voltage is given to the motor. Then again, this joint will move this way. So every time until you reach the required position, this is keeps on calculating. So for that we need a mathematical model. Okay, then next comes the servo motor. So we have AC servo motor, DC servo motor, and brushless servo motor. Why do we use servo motors? It produces high torque at all speeds, including zero speed, high torque. Then they are capable of holding a static. Even when there is no motion, it is able to hold the particular position. Then it will not overheat, okay, or at standstill or lower speed. Then due to low inertia, they are able to reverse the direction quickly, because if you have more inertia, then you have more resistance. It takes time to move one forward or reverse direction. So they are able to accelerate and deaccelerate quickly. So these operations which are required to operate the joint, to actuate the joint, we need a servo motor. The first motor is the DC servo motor. So DC servo motor, we can say that its feedback is with this servo motor. It's not a open loop, it's a closed loop. You know how? Because these are the components. So if for a DC motor, you have a sorry, for DC servo motor, you have DC motor, you have a gear assembly, you have a position sensing device, you have a control circuit. Okay. So how it works is, first the sensor, potentiometer we always use. So potentiometer is so this is a coil, and then here, so this is the voltage. Usually we give 5 voltage, and then this is the slider. So when the slider moves up and down, the voltage will be different. Okay. So the potentiometer output is measured in terms of voltage. So that voltage is given to the, because so that is the current voltage. Okay, current position. So that position is given to the control circuit. This is the current position. And then already you have a DC motor. Then based on the position, the control circuit will decide how much voltage should be given to the motor, so that the motor will be energized. So once the motor is energized, so to this the gear arrangement is attached, so that so here we have three sets of gear arrangement. It is to amplify the actuation. Okay, so this is how it works. Since every time we measure the current sensor value, so it is called as closed loop, because based on the potentiometer value, the control circuit output will be different. So hence it has got the name, or DC motor is an example for feedback device or closed loop system. Okay. Yes, this is explained over here. So the motor, which are utilized as DC servo motors, generally have separate DC source, which has field winding and armature winding. The control can be achieved either by controlling the field current or armature current. Okay, so most commonly, and then it is just 200 rupees in the industry. The students, those who want to try with different manipulators, they always use this motor, because if you just buy sensor, you don't need to buy a separate unit for motor or a sensor or a control circuit or a gear arrangement. So this is the motor in which you have everything. So people go for this, and if you want like specific actuation, then uh, because here all in one circuit. If you buy one servo motor, you have sensor, motor, and gear. So as I have said, so here you should have gear, a motor, and sensor. All these in servo motor. All these, this package is this complete thing. Sometimes if you are not okay with the DC motor, then you have to go for stepper motor. So stepper motor means, then for gear arrangement you have to devise one mechanism. For that you have to find out the turn ratio or a reduction ratio or amplification ratio, and we have to buy one encoder. So it depends. The people may go for servo motor, or the people may go for stepper motor, and then this mechanical assembly for the gear arrangement, then any sensor, okay, any displacement or any position sensor, okay. Then application of DC motor already we have seen, because high torque, okay. Uh, okay, and this is one application of servo motor. So actually this is the gripper. So here is this is the end effector gripper. It keeps the bottle here, and then this is the conveyor. Based on the input given to the conveyor moves. Okay, based on the speed. So the speed is calculated based on this action. So here in this, so we have three manipulators. Three manipulators is with the end effector. The first end effector, you have a gripper. So this gripper will keep the bottle over here, okay, and then that bottle is moved to the next one. So here one more gripper which fills it. So once it reaches this point, you have a sensor. The sensor says this is reached, so immediately it is on, and then the liquid is filled, okay. And then one more gripper, so it will fix the cover, this bottle cover, and then it moves. So these are all servo motors, and here also it is used to pick and place. So here this end effector is gripper. So this is one serial manipulator. Why it is serial manipulator? Because one end is fixed, the other end is free, and then the degree of freedom is, since it is serial manipulator, the number of joints equal to number of degree of freedom. So one joint, two joint, and three joint. So the degree of freedom for this manipulator is 3 DOF. Okay, and then the end effector you can use, and then yeah, you can see the length. So here also one more joint. So this is rotation. This is rotation. This is also revolute joint, and then this is also revolute joint. And then see here it extends. So here you have prismatic joint. So I can say totally 4 degrees of freedom. One, two, three, and then prismatic. So it is 4 degrees of freedom. So here based, because for each joint you have that servo motor. The servo motor will tell you how much it has to move, so that it can move, it can pick from here and it can place here. Then here is the gripper. Okay, so this gripper grips it and keeps it over here. So this is one very good application of the serial manipulator for pick and place operation. So here you can see the gripper. So this gripper can be mechanical as well, because the force, how much ever force you give, automatically this gap will be extended, or it will be narrowed. Okay. This is also one more. So here is a conveyor belt. So here this sensor says that object is detected. So this sensor will give the information. So here we have two operations. One is clamping, another one is drilling. Okay, so here for this clamping we can use some pneumatic circuit. You can use a pneumatic circuit. So here you have a cylinder. So when you give pneumatic signal to that, then this will be moved up and down. Okay, for example, uh, so this is your cylinder. Okay, this is the piston. Okay, if you give force to this piston will come out, and then if you release the pressure, it comes back. Extended, retracted, extended, retracted. So, and then here you can have a clamping device. So this is a pneumatic device. So you give the power supply so that this piston will be moved left to right. So that is the clamping. And then here you have a robot. So this is the end effector. In the end effector you have a tool. This is the tool, so which will make a hole on it. Drilling it makes a drill. And then this is the conveyor. So to run the conveyor, we need a motor. So how it works? So first, the sensor says the object is detected. So that information is given to the control system, the control circuitry. The control circuitry will give the signal or will actuate this manipulator. Then will actuate this as well and will actuate this as well. And then when the object is detected, so it actuates the serial manipulator so that the end effector in which we have a tool. So the tool will be operated and it makes a hole on it. Okay. So for this actuation, so here the joint will move up and down. So we can use prismatic joint mechanism over here. So this is one example. And then the spots. The spots are using this mechanism. The spots are rolled so that parts are collected, the components are collected over here, and then this is clamped and drilled. So this is one example of an autonomous system in which the robot manipulator is used to clamp and to drill. Okay. Then see, we have already seen that the torque, the torque produced by the control system. This is the desired torque. That torque has to be given to the driver circuit. The driver circuit says when to switch on the windings, when to switch off the windings, switch off. So one such driver circuit is H bridge. Okay, H because it looks like H shape. So consider this is a motor. So this is A and then this is B. Okay, if I want to have forward direction means this is forward direction. If I want to have forward direction, I have to give power supply to this. I have to on this, I have to on that. So this has to be off. If I on this switch and this switch, automatically the positive power supply will move and then it will energize this motor and then it is grounded. Okay. So this is forward direction. If I want to switch off this and if I want to on this or if I want to on this, so this is in the it can take this path and it will be energized. So this is the reverse direction. Okay, so this is reverse direction. So S1, SW1, SW4 is for forward direction. Then SW2, SW3 is for reverse direction. So likewise, we can control the circuitry accordingly. The particular winding is energized. Then we can have forward direction and reverse direction. So this is one H bridge driver circuit. So the next comes the stepper motor, which the stepper motor is the open loop motor. The servo motor is a closed loop motor. In stepper motor, we don't have any sensor or gear arrangement, just a motor. Okay, so how it works? So it provides rotation in the form of discrete angular step. That is, if you give one pulse, it moves. For example, so if you attach stepper motor to this, then based on the input, it moves one step. And then for the next step, it moves the step. For the next voltage, it moves. So likewise, it moves step by step, step by step. So this is the angle. So maybe it could be 1 degree or 2 degree. So step by step actuation is possible using this stepper motor. So how do you get this? So this is using open loop control system. So each step angle is actuated by a discrete pulse. So based on the pulse. So for example, here the overall, I mean the entire thing is 360-degree. So how many poles you have? So here 1, 2, 3, 4, 5, 6. So by 60-degree, and then so it is okay. So each angle is 60-degree. Okay. Um, Sorry, to start 60-degree. So 1, 2, 3, 4, 5, 6, 7, 8. So 360 by 8. Okay. So here 30 to 40, 45 degrees. Okay. So for each step angle, so this 45 degrees. So it moves like this. It moves like 45, 45, 45, 45. So that is decided by number of this the split up or windings. Okay. So why do we need stepper motor? Because it is inexpensive. It's ideal for open loop system. It can implement it without feedback. Then just count the steps. It's very simple. It holds its position firmly when not turning, eliminates mechanical brakes, better torque than DC motors, and positioning application. It's very good for positioning application. Then how do you find out the steps? Step angle is very, very important. So the number of steps, how many number of steps? Okay, so here totally eight number of steps. Suppose if you want to have 36 steps means then the angle is 10 degrees. So likewise, you can decide the number of steps. Accordingly, you can find out the step angle. Okay, then this is how we can find out the angular velocity. And then this is the total angle. Okay, and we'll see the construction of the stepper motor. So in this we have stators and then rotors. So when the stator is energized, accordingly this will be energized. Then this rotor will also be energized. So there is a motion. Okay. So stator whole pulse multiple windings. You can have multiple windings also. The rotor is magnetized or not magnetized based on the uh, power supply given to the windings. So this is how it looks. So here North Pole and South Pole. Okay, so green one says it is energized, red one says it is not energized. So let's see, uh, because once again I will repeat. So this is a joint control system. From the joint control system, it provides the torque. So this torque is given to the driver circuit. Then the driver circuit will produce as VA armature voltage. Then that is given to a motor, any motor, then that is given to the joint. It is This is how it works. So in this slide we'll see the driver circuit. What are the different driver circuits for this? Okay, so first one is full step control sequencing. In this you have only four sequences, one, two, three, four, because it is full step. Okay, so in this case, suppose if this is energy, so this is a microcontroller, because the microcontroller will provide you the pulse. Because this is a processor, the processor will provide you the pulse. It says that on which time it will give 5 volts. So this is one means it is 5 volts, which is it is enough to energize this winding. The other ports are 0. Okay, so that information is given. So in this, you can just map with this. So here this is 0, 0, 0 and 1. So which means B dash is energized. So B dash is energized. So if this is energized, the current passes through this. So since it is energized, this produces north pole. So in this way, your the poles are energized or the windings are energized. Okay, in the next, so this is how only one phase is on. Okay, in the second case, you have 110, which means, so here, yeah, the 001. So you can just map with that. So which means your B and, so here, yeah, this is A, and then this is B. A and B are energized. You can just map with this 1100. So in this, your AB is energized. AB. Okay. Since A is energized, so this is positive. This B is energized, this is positive. So you can energize in this fashion also. Okay. The next case, you can energize A dash and B dash. So since A dash is energized, so you have positive, this positive, and then B. Okay, so B means this one B. So likewise, you can energize in various fashions. So this A dash and B dash, and then and then the next one is A B dash. So likewise, you can energize the windings based on the requirement. So that requirement is decided by the microcontroller. Okay, then next one is half step. Half step means you have more number of sequence. So it is 8. Okay, so accordingly we can energize. So here let's say some example. So in the first case only A is energized. Okay, so accordingly you have to give the signal. So this A is energized, this is positive. So in the next case AB is energized. Okay, so if AB is energized, see the pulse. So here 1 and 1. Okay, the next case B is energized. So B is energized means, so this is this one. So this is B. Okay, so B is energized means this. And then next one is A dash B. So this is B and then this is A dash. So A dash B both are energized. Okay. The next case, so this is B, this is A dash, only A dash is energized. In the next case, both A dash. So this is so here I can say B, B dash, and then this is A, B, B dash, and A dash. So accordingly, the particular winding will be energized. So this is how we can energize the particular winding, and you can provide the required armature voltage. With that voltage, the motor will be rotated. I mean, the motor will be energized and it will rotate the joint. So this is one example for driver circuit. So thanks for watching. That's all for today. Thank you.